remember your energy lessons from grade school and high school, then you could probably skip this lecture. But if you don't, this is just a quick refresher about the types of energy. Simply put, energy is the ability to do work. There are two main types of energy, potential and kinetic. So potential energy would be like the energy stored in a spring, or gravitational energy, so that's dependent on the height you are from the ground, or if the object is from the ground. Chemical energy, energy stored in food, and then mechanical energy and nuclear energy. So those are all potential energies. Kinetic energy is the energy of motion, and some of the examples here, at first you think that's not really energy of motion, like thermal heat. That is the energy of motion because the atoms in a compound are vibrating, and they vibrate more if they're hotter. So it actually is energy of motion. So radiant energy from the sun is energy of motion. Thermal or heat energy is sound. Those sound waves are moving, compressing the air. Electricity is energy of motion. It's the movement of electrons. And then of course motion is the energy of motion. So a roller coaster moving downhill is kinetic energy. In life, we're always transforming energy from one form to another, and that is subject to the law of conservation of energy. So this is going now from elementary school to high school, where you probably learned about conservation of energy and the fact that energy can't be created or destroyed. So when we talk about energy production, really it's just talking about the conversion of energy from one form to another. But it does get confusing because people always talk about producing energy, especially with electricity, and you're not producing any new energy, you're just converting the energy from one form into electricity, for example, which is a kinetic energy of movement of electrons. Energy, this transformation from one form to another, it's only 100% efficient, what we call efficient, if all of the energy is transformed from one form into the other. But this never really happens in real life. So for example, if you have a combustion engine car, when your car is converting fuel energy to motion, only about 30% of the fuel energy that is released during combustion is able to be converted into motion to power the wheels to make the car go down the street. Most of the energy is lost to heat because of friction and moving parts in the engine and in parts of the car, and then this heat just dissipates to the environment and is lost. So it's not being used efficiently to power that vehicle. And there's a number of examples here of energy transformation. So if you eat some food and your body burns up that food and then gives you energy to power your bicycle. The radiant energy from the sun gets harnessed by plants and they turn it into chemical energy. Gasoline is a chemical energy that when you combust it, it powers your car. And then electricity is a wonderful source of energy for us to use because it can easily be transferred into other types of energy like thermal energy to power your stove or your oven. There's other classifications of energy when we're talking about energy that we consume, and these are renewable versus non-renewable energy sources. So a renewable energy source is any source that gets replenished naturally on a regular basis. So like solar energy gets replenished every day. Every day the sun comes up and there's a continuous source of that solar energy. So another way to think of it is it's replenished faster than we can consume it. So some examples of that would be solar, wind, hydro, geothermal, and biomass energy. Those are all renewable because we are able to replenish them faster than we're consuming them. Fossil fuels and nuclear energy are considered to be non-renewable energy sources. This is any source of energy that's limited and being consumed at a rate that is faster than it took to form these. And so fossil fuels include oil, natural gas, and coal. These took millions of years to form underground due to decomposition of old plant and animal matter. And then uranium, which is the source for nuclear energy. There's a finite amount of uranium on Earth's surface, and so we're consuming it. You can't create more of it, so we're just consuming it. In the United States, 89% of our energy still comes from non-renewable energy sources. So as much as we hear about these wonderful renewable energy sources, we're really not using them much more than we used them 10 years ago. There's also another classification of energy called secondary energy sources, and these are basically energy carriers, so ways that you can store, move, or deliver energy in a way that you can use it. And so two examples of this would be electricity and hydrogen. So hydrogen fuel cells you've probably heard about. These are both formed from converting other sources of fuel into energy that can be, then used as electricity or hydrogen gas. So these are they're called secondary energy sources because they're an easy way to deliver energy. Okay, so where do we consume this energy then? So we consume energy in four main sectors, and they're referred to generally as sectors. So there's sources of energy, which would be the fossil fuels, nuclear, renewables, those are all sources. And then the sectors are the areas in which we consume energy. And really we're just consuming those sources that we discussed. And then a secondary source would be electricity. So the four main sectors are residential and commercial buildings. So we use energy to heat buildings or to pump water to buildings. Industry, so whenever industry does manufacturing, agriculture, mining, and we have to power the machines that you need to do those processes, so that's how industry uses energy. Transportation sector uses a lot of energy to get us around, so it powers the cars and trucks and planes, boats, subways, buses, all of anything that has an engine on it that's going to propel you has to be powered by something. And then electric power generators, so that's considered to be a sector, electric power generation, because that's where the source is being used to create a form of energy that you can then use. And most electric power generators use the very similar technologies. They almost all use a turbo generator, also known as a turbine, that converts either steam, pressure from steam, or in the case of like a windmill, the turbine is being just pushed around by the wind, and then there's a generator inside that converts that energy of motion, or the steam pressure. It pushes the turbine, and then that creates electricity through an electromagnetic system.